Summary. In previous sessions, you have learned about the different types of assignment statements and flow control statement in detail, and the actual circuits generated by them, the IC. Here is a simple summary of all statement you have learned in the previous sessions. When you want to generate a combinational circuit, you can use either assign or always_COM blocks. Use assign if your combinational logic can be represented in a single line, otherwise use always_COM. When you want to generate a latch-type circuit, that is a storage circuit without clock signal, use the always_latch block. When you want to generate flip-flops, uses always_FF block. You can use all the flow control statements in any always_COM, always_latch and always_FF block. Here the general purpose always block is intentionally skipped. If you are coding in Verilog instead of Systemverilog, apply the synthesis guidelines learned in the third session, to generate different types of circuits in the IC. Finally, you have reached the end of the course. This was an intermediate-level course in Systemverilog programming, focusing only the assignment statements in it. In this course, you were introduced to the different types of assignment blocks in Verilog and Systemverilog. You have learned all different flavors of the always block in detail in order to model sequential and combinational circuits. Also, you have learned the effect of using blocking and non-blocking assignments in simulation and synthesis. Finally, all types of flow control statements in Verilog and Systemverilog were explained, and each of them were mapped to the final circuit generated in the IC. Now it's time to practice what you have learned in this course. If you have an option to do synthesis in your company or university, you can code very simple circuit and analyze it after synthesis. If you do not have, don't worry. Write the code in Systemverilog by knowing what will be generating in the final IC, and simulate them. When you write multiple complex nodules, it is practically impossible to always map each and every part of your code to the circuit components. But remember, that is the expectation when we write the functionality in an HDL, and leave the overhead burden of generating circuits to the synthesis tool.